So in the case of pairwise alignment and multiple sequence alignment, we already have an idea what is pairwise alignment and what is multiple sequence alignment. Anjana and Abhinandana, please keep quiet. So in the case of this multiple sequence alignment, basically sequence alignment is a bioinformatics technique, and that is mainly used for comparing regions of similarity in a nucleotide or in a protein. That is the main aim of the sequence alignment, and these similarities can provide insight or information into evolutionary relationship between these sequence. And the two main types of alignment are pairwise alignment and multiple sequence alignment. So we have already seen what is a pairwise alignment. So in the case of pairwise alignment, we had seen that there will be two types of sequence. One is a global alignment, another is the local alignment. Global alignment aligns the entire length of both sequence. That is the idea of the global alignment. Now here the algorithm that we are using is Needleman-Wunsch. We have already seen that. Second one is a local alignment. It aligns only most similar subregions of the sequence. So that is the local alignment, not entire alignment is given. Now here the algorithm is Smith-Waterman. So what advantage of local alignment is that it will be useful for sequences that difference in length or share regions of, so for example, one sequence is 10 centimeter long, another sequence is 1 centimeter long. We may not do the global alignment. So we cannot stretch the 1 centimeter to 10 centimeter. That is impossible. So global alignment is only possible where sequences are similar length, whereas local alignment is possible when sequences are of different length. Now what are the steps in the pairwise alignment? One is giving score, assigning scores for matches, mismatches and gap. For example, if there is a match between two sequences, here you can see that if there is a match between two sequences, we will give a value of, for example, here you can see that T and T is similar, A and A is similar. So when such kind of similarity is coming, we will give a positive value of +1. Now if there is no similarity between them, here the AT and here there is no similarity is there. When there is no similarity is there, we will be giving -1. And another type of is where there is no letter between the sequence, we will be giving them a gap. Here you can see that there won't be any letters between them, then we will be putting a gap there. Here you can see that we are putting a gap here. So for a gap we will be giving a negative value of -2. So based on this calculation, there are certain software that will be finding out the maximum value of similarity and maximum value of dissimilarity, and it will show us that this sequence and this sequence have 95% similarity or 99% similarity. So when we are doing the BLAST, we can see that we are putting a sequence into the GenBank database and we are giving a result. There is 98% similarity with your genome, or there is 99% similarity. So then we can somewhat be sure that our sequence and this listed sequence are same. So here the main idea is that to identify the optimum alignment path by tracing back through the matrix. So here you can find also the applications of pairwise alignment already we had seen. Then multiple sequence alignment involves aligning 3 or more sequences. If only 2 sequences are there, we call it as pairwise alignment. If more than 2 sequences are there, we call it by the name multiple sequence alignment, and we will be finding out the regions of similarity or conserved. Conserved simply means permanent. They do not have any change. Regions in an evolutionary process. Then what are the main challenges in multiple sequence alignment? One is computational complexity. For example, here we are using a smaller sequence to only 2 sequences, whereas here we are using more than 2 sequences. So this is how we are finding the regions of multiple sequence alignment. Then going to the methods of multiple sequence alignment, we have progressive alignment, iterative alignment, and consistent alignment. So coming to the multiple sequence alignment, now you have an idea. This lower one is the multiple sequence alignment. If you want, I will show you another picture also. See, here also you can find this is multiple sequence alignment. See, this is the multiple sequence alignment. See, this is multiple sequence alignment. More than 2 sequences will be aligned. Let's see here. This is another picture. So these are all very small pictures. Okay. This one is better, I think. See, here you can see that more than 2 sequences are aligned. When more than 2 sequences are aligned, we call it by the name multiple sequence alignment, and that is the main idea in the case of multiple sequence alignment. And there are 3 methods in multiple sequence alignment. One is progressive alignment, iterative alignment, and consistent alignment. Progressive alignment builds alignment incrementally using a guide tree. That is a evolutionary software. We have different type of software like cluster, mapped, etc. Advantage is that they are faster and suitable for larger data set. Whereas iterative alignment refines the alignment iteratively to improve their accuracy. And we have muscle and prank. These are the 2 software which are primarily used for iterative alignment, and that will be giving a high accuracy, and errors can be corrected also. That is one advantage, but computationally it is very difficult. Then we have consistent alignment. Use consistency based scoring to improve the accuracy. A software that we are using is T-Coffee. So T-Coffee is a popular type of software, and that will be giving. So these are the 3 different methods of multiple. How we are finding out this multiple sequence alignment. All these are actually based on computational programs or computer software. Without that, it is impossible to find out the regions of similarity. See how this multiple sequence alignment is actually done. Different steps are there. We have to input the sequence. We have to construct a tree. Use pairwise alignment to create a phylogeneity tree. Then we will be using progressive alignment. Then we will be also refining the alignment based on the consistency. So this is an idea regarding how multiple, because you don't need to study deeper into the process of multiple sequence alignment. You just want to have what are the applications, how this process is actually done. So regarding the multiple sequence alignment, their main application is in phylogenetic analysis. So when we are doing something, for example, if we are doing some biodiversity study, and if you want to compare your species with some other species, multiple sequence alignment is a very good thing. So based on that, we will be able to find out, because we can say with 100% accuracy that our species and this species are similar. Because if DNA is similar, then they will be similar. So that is the main idea of the multiple sequence alignment. Here you can find what are the major similarity between pairwise alignment as well as the multiple sequence alignment. So this is how the differences between pairwise alignment and multiple. See here you can see that in case of multiple sequence alignment there is more complexity, and these are some of the popular program: cluster, muscle T, coffee, maft. Whereas here we are mainly using blast, needleman, smith, waterman. So these are some of the softwares which we are using in case of pairwise alignment and in the case of multiple sequence alignment. So most of the time we can expect questions based on this. They will